Ladies and gentlemen, welcome to IET London, Savoy Place. There are no scheduled fire alarms for this evening. If you hear the alarm, please go through your nearest fire exit and make your way to the meeting point under Waterloo Bridge. Staff will be on hand to lead the way. Tonight's EngTalk will begin shortly, so please take your seats and ensure your mobiles are turned to silent. Thank you. Welcome to tonight's IET EngTalk, inspired by the life and work of Lord Mountbatten. Lord Mountbatten was President and Honorary Fellow of the Institution of Electronic and Radio Engineers. He served in the Royal Navy and on the outbreak of the Second World War was captain of the destroyer, Kelly. Winston Churchill appointed Mountbatten head of Combined Operations Command in 1941 and 3 years later head of the Southeast Asia Command. Upon his return to service at sea, he was appointed First Sea Lord in 1955 and Chief of Defence in 1959. The Mountbatten Lecture itself was established in 1978 by the National Electronics Council. The very first was delivered by Lord Mountbatten. After his assassination the following year, the lecture was renamed the Mountbatten Memorial Lecture in his honour. We're delighted to present for you tonight the first IET Mountbatten EngTalk. Ladies and gentlemen, please welcome your host for this evening, the Royal Air Force's Head of Diversity and Inclusion, Wing Commander Sarah Maskell.
So, welcome to Savoy Place and this evening's EngTalk. I first of all must offer an apology for the slight delay. It was just so popular. There are so many of you in here, we've literally had to manage seat by seat. My name's Sarah and I'll be your host for this evening as we hear from tonight's speakers, Dr. Julia Sutcliffe, followed by Air Marshal Julian Young. There will be time at the end of the second speaker session for questions if something catches your eye. I would also like to make a special shout out to the cadets from Welbeck Defence College. You can make a noise. Yay! Well done. And anyone catching up at home or watching on IET TV. Hello. I'd like first of all to get started and introduce Tim Knatchbull, who is Lord Mountbatten's grandson, to the stage.
I wonder what, yes, great. So my grandfather, Lord Mountbatten, had this endearing habit of clasping his hands tightly together whenever he was pleased at the way things were turning out. He went like this. This and countless other memories burn bright today. One of the enduring passions that he always exuded was for engineering and technology. In the Navy as a young man, he had become a signals specialist and wireless operator. And from the 1930s, he was an ardent member of the Institution of Electronic and Radio Engineers and was twice their president. The IERE was a forerunner of the IET, that unique organization that has so brilliantly assembled us here tonight. Now, on the eve of his 65th birthday, the institution presented him with a piece of cutting-edge technology, this Travel Master dictaphone. It was a perfectly timed gift. As he prepared to step down from his role that month at the head of the armed services, he was going to lose much of the secretarial support and other support that he needed for his prodigious quantity of correspondence, speeches, and travel. He had decided that for his next challenge, he wanted to lead the international development of an educational experiment promoting peace and international understanding, bringing together young people on scholarships from around the world. At that time, there was only one such school in the world. It was called Atlantic College in South Wales, started by the German educationalist Kurt Hahn. And from this small beginning, a network of what became known as the United World Colleges would grow. With the help of this amazing piece of bleeding-edge technology, by the time he stepped down in 1978, the United World Colleges were set on an upward path of growth. Today, UWC is the largest educational organisation of its type in the world, with 17 colleges and schools and committees in 159 countries. And we're very pleased to have here tonight from UWC's International Executive Director, Jens Valterman. After my grandfather's assassination in Ireland in 1979, the dictaphone remained in the UWC's international office in London. And today, thanks to Jens and his colleagues, it is coming home here to the IET to go into their dazzling exhibition, 100 Objects That Changed the World. And if you haven't seen that already, it's on the first floor. I really suggest you have a look. Now, Grandpapa would have been especially pleased by the interest shown in this story by another keen engineer and technologist from Mountbatten stock, Prince Philip, his nephew, who also has strong UWC connections, having been taught by its founder, Kurt Hahn, at Gordonston in Scotland. Recently, when the Prince heard that UWC and IET were getting their heads together, he sent me a note. "What about the Royal Academy of Engineering?" he said. And to their great credit, and I'm sure much to the pleasure of their senior fellow, Prince Philip, the Royal Academy of Engineering are here tonight, represented by Chief Executive Dr. Hayatun Sillam, to witness the handover that will happen in just a minute of this piece of technology, and to be part of this great evening, and hopefully to sit down with UWC and IET and work out a way to bring together the amazing engineering, technological and educational brains assembled here. Personally, I hope that a programme of engineering and technology scholarships might grow from this collaboration. And tonight, I can announce that as a direct result of the IET's Mountbatten EngTalks, a pledge of £9,000 has been received to help support the UWC's quest for scholarship funding. If my grandfather is looking down on us tonight from his cloud in engineering heaven, you can be sure his hands are clasped firmly together. And he would also be telling me to clear off the bloody stage so we can listen to tonight's two extraordinary speakers, Dr. Julia Sutcliffe and Air Marshal Julian Young. But to IET, to the Royal Academy of Engineering, to United World Colleges, and ladies and gentlemen, to you for your patience, thank you very much indeed. And now I'm going to ask the president of IET to come up so that I can present the dictaphone so that it can enter back into IET's safekeeping. Thank you. Nick. We have a time. Just excuse us for a moment. And again.
We need to sneak up behind them. We can have that round of applause again. Perfect, thank you.
Thank you very much.
Just in case you missed it, Lord Mountbatten's dictaphone will be housed here in Savoy Place in the IET's 100 Engineering Ideas That Have Changed the World display. It will also be available to view in the reception room after tonight's lecture. I'd like to invite to the stage our first speaker. Dr. Julia Sutcliffe is the Head of Engineering for BAE Systems, covering the design and development of training systems for pilots and technicians. Her team delivers simulators, classroom systems, and increasingly VR-enabled capabilities to the Royal Air Force, as well as many other customers and air forces overseas. She's passionate about encouraging girls and women into engineering and volunteers with different organisations to help this happen. She's about to move into a new exciting role as the Chief Technologist for the air sector at BAE. Dr. Julia Sutcliffe.
Good evening, ladies and gentlemen. What a great pleasure it is to speak to so many of you this evening on this landmark year for engineering. The Royal Air Force centenary celebrations have been fantastic to watch, and I look forward to Air Marshal Young's thoughts on the next 100 years later this evening. I'm sure many of you have also been involved in activities up and down the country to celebrate 2018 as the year of engineering. And as if that wasn't enough, here we are on the cusp of the fourth industrial revolution. which is creating an unprecedented rate of change in the technology sector and a huge opportunity for innovation. And so I ask, is the sky still the limit for air sector technologies? Will a new set of capabilities emerge from Industry 4 that redefine, reshape and reset the products that we create and the way in which we create them? So let's understand why Industry 4 is being heralded as a revolution. So the first industrial revolution, the one we probably all learnt about at school, was powered by steam, and it allowed mechanisation, and it transformed industries such as textiles, mining, transportation, and with it, our very way of life. The second was powered by electricity and brought mass production, and industries such as steel and petrochemicals and automotives emerged. Big change in our way of life. The third was catalysed by the rise of electronics and computing, which allowed automation and another step change in leisure and in businesses. Now, only 50 years later, Industry 4 builds on those digital foundations and propels us into a new era of cyber-physical systems, where technologies such as AI, cloud computing, the Internet of Things are disrupting and transforming businesses globally. And it's that pace of development and that reach that looks set to create the conditions for a profound impact. I'll quickly show you this chart from the Gartner organisation. It's their hype cycle for emerging technologies and gives their view of what will mature and when. Some technologies you can see on here are already here today, such as VR, whereas others are in development and less mature at the moment. These charts are important for us in the air sector when you think about the development timeframes of our products, often decades, and the even longer in-service lifetimes, which can be 40 to 50 years and more. So it's our challenge and our opportunity as a community of engineers, technologists and scientists to create products that can bring in these new technologies as they emerge and understand how we exploit the technologies today into our existing product set. Certainly, old notions of a single design freeze and expensive single midlife upgrades belong to the past. So let's look at some of these technologies in more detail. Okay, so big data. Oh my days, that's an understatement, isn't it? So some fun facts for you from the Shift Happens video that you can see on YouTube. There are 540,000 words in the English language, 5 times as many as in Shakespeare's time. This year, between us, we'll generate 4 exabytes of information. That's 4 billion gigabytes of information. And I think I read somewhere that we'll upload 300 hours worth of video material to YouTube every minute. And in 20 years' time, there'll be 10 billion of us on the planet with 100 billion connected devices, gobbling up bandwidth at a phenomenal rate. And in the air sector too, airline entertainment systems generate gigabytes of information on a single flight. Onboard health and monitoring systems generate hundreds of thousands of data points. And military aircraft systems generate far more data with the mission systems than could possibly be analysed by a human being in real time. And yet our expectation is that our watch, our fridge, our car, our central heating system are all connected and can talk to each other and optimise our environment without us having to continuously control it. So could that be a vision for the air sector? Could we have aircraft systems that gather not just mission data, but health data, pilot performance data, talk to each other, talk to the future hangar, talk to the supply chain before landing, so that that repair, refit and turnaround environment is optimised without us having to control everything? So if this vision is going to happen, it will need underpinning with some very quick computers and some clever software. So fortunately, processing power is still doubling in accordance with Moore's predictions. But we also have the prospect of neuromorphic computing on the horizon, which promises processing speeds and very small volumes and low power. And if that's not enough, quantum computing clouds look set to deliver computational speeds that are simply not conceivable by any other means. Machine learning and cognitive computing has also seen huge advances recently, partly because of its commercial application in things like weather forecasting and with organisations such as Netflix, but also because of the vast amounts of data that are available today to train these algorithms. So there's a picture there of the AlphaGo software, DeepMind's AlphaGo software, that was trained with thousands of moves that human Go players had devised. It won the World Championships in 2016. But then AlphaGo 0, the update, was trained entirely by playing against itself. And it outperformed all previous versions of software, all humans, and also created moves that no human had conceived of before. So data, computation, machine learning are taking us to a new place where we could process those vast amounts of data, we could augment human performance, and we can create designs that hitherto we had not conceived. So we're all familiar with unmanned systems, from quadcopters to the Intel shooting star drones we saw at the Olympics, and driverless cars. Operationally, unmanned systems typically do the dull, dirty or dangerous jobs, and come in all sorts of shapes and sizes, from simple inspection drones there to the US Navy's firefighting humanoid robot, to the UK's ironclad system for medical evacuation, and complex, sophisticated systems with multiple sensors doing image processing, navigation and decision-making. But it's actually that dual use of those technologies within the commercial sector that means that actually some of those navigation, image processing and decision-making algorithms can be bought off the shelf. So we can actually spend our resources envisaging innovative and affordable applications of that technology that were hitherto impossible. At the bottom there in the middle, there's a concept of ultra-high formation flying to get a swarm of drones out onto an operational environment. Not even the Reds would fly that close. So conventional assumptions on development timeframes, operating costs and the role of the human and the machine are changing. We see some really lovely examples of humans and machines working cooperatively in manufacturing, which is right at the heart of Industry 4 and a hotbed for innovation at the moment. So as well as robotics, we have cobotics, where machines work safely and cooperatively with humans in the smart factory. Exoskeletons reduce the strain on human workers, and robotic maintenance aids, from large-scale refueling arms to nanobots that inspect, are here today. And when we have 5G and the tactile internet, we'll have telepresence. So I could actually fix something without being there. I could do that from home. Wow. Additive layer manufacturing is also part of this revolution, allowing us to put matter where it matters and build things better, cheaper, faster. At the bottom picture in the middle, on the left-hand side, is a camera bracket from the Tornado aircraft. It's milled conventionally from a block of metal. It's robust, but it's heavy. It wastes material in the milling process, and it's time-consuming. In the middle, you've got some designs that, through a topological optimization, have been created. You couldn't mill those, but you could print them. But on the right-hand side of that picture, with AI further optimizing that topological design, you've got something that is optimal weight and strength, but no human would design that. And then if you go further out into the future, you're into the really innovative space of computation, being pioneered by Professor Cronin at Glasgow University, where algorithms can create large-scale structures from nanoscale compounds through a process of chemical self-assembly. Wow, food for thought. So our relationship with software and machines is changing. AR and VR are giving us new ways of visualizing all of that data and of interacting with systems. You can see here a picture of a control center with humans, AI agents and avatars interacting. Remote collaboration through virtual co-location becomes simple and does away with the need for expensive hardware interfaces. And control cues come from natural voice, as well as eye tracking and haptics. And by incorporating physiological measurements, when a human is under stress, actually we could dial up or dial down the degree of control undertaken by the system accordingly. So these changes are occurring right the way across the life cycle. Clearly, with AI-enabled systems, off-the-shelf algorithms and masses of data, secure comms and cyber resilience will be key to any future vision. Of course, the comms chain starts in space these days as we put ever more satellites into space by ever cheaper means. Clearly, as we move data around the globe at high speed, we want to protect it and the systems on which it resides. And the Internet of Things world and open architectures and commercial applications may appear vulnerable, particularly given the brute force of quantum computation and the potential to break traditional encryption. So system architectures that are decentralized, dynamic, are part of the answer, with AI techniques and data guards that can quickly spot a breach, quarantine, reconfigure the system and reallocate. And interestingly, quantum mechanics may come to our rescue here with the property of entanglement, or what Einstein called spooky action at a distance, meaning we could potentially create an unbreakable cipher secured with the laws of physics as opposed to mathematics. So this overall system of system design and performance can be captured in a digital twin of the complete enterprise, from space-based assets with neuromorphic computing, quantum encryption, to AI-enabled aircraft systems that gather mission data, health data, pilot performance data, and talk to the future hang of the supply chain. Accurate models of every aspect of the system are developed, and all aspects of the operation are monitored and recorded and optimized through life. Massive compute power, AI, VR, are capabilities that will be used by multidisciplinary teams to rapidly create and visualize totally new designs with low-cost test and certification cycles that can be rapidly manufactured. And whilst not all technologies will mature in the timeframes, the pace of development is beyond anything that we've experienced previously. So I ask, is the sky still the limit for air sector technologies? So it's a bit of a play on words, but for the air sector, much of our technology and capability has absolutely been about airborne performance in order to support our RAF customer in control of the air. And the aircraft itself was, of course, a product of the second industrial revolution. So what will be the products of this one? Will cyber-physical systems create a completely new paradigm? Our customer is talking about control of air, space, and the world of cyber. So we have a unique opportunity right now to capitalise on Industry 4 and innovate to create the products and services that will be required by our customers in the years ahead. Thank you for your attention.
Thank you, Julia. Quantum clouds and shooting star drones. I've definitely learnt something about this evening. Thank you, everyone, for listening to such a fascinating programme and presentation. There will be an opportunity to ask Dr. Sutcliffe questions later. I'd now like to introduce our next speaker. I'd like to introduce Air Marshal Julian Young, Senior Officer responsible for delivering Defence Equipment and Support, or DE&S, in the air environment. He leads an organisation of some 1,950 military and civilian staff, and manages a budget of £3.3 billion for equipping and supporting the MOD's fixed-wing aircraft. He's the focal point of contact within DNS for the Royal Air Force. He's a member of the Air Force Board, Chief Engineer for the RAF, and to top it all off, he's the Defence Champion for Engineering. Sir?
Well, good evening. It's, I have to say, a great privilege to have been asked to come along here this evening and speak at the Mountbatten Memorial EngTalk. It's really fabulous to be here. It's great to be a trustee of the IET, which I really enjoy, but most of all, it's just great to be an engineer. And I promise that I'll try and get away from the stereotypical view of the engineer. I'll try and not get into too much detail, even though I would really love to, and I know all of you would too. I also will try and be interesting, but only you can judge that at the end of it, I guess. Can I just ask where Welbeck College students are? Right, so I'm just trying to win friends and influence people, and as far as I'm going to be their graduating officer for Upper 6th on the 7th of July, and it's always good to get part of the audience on your side. So I'll see you on parade on the 7th. Looking equally as smart as you do now, I am sure. Gosh, who can tell what the Royal Air Force is going to look like in 100 years' time? I'm going to throw some ideas out there, and indeed, if I may, also to congratulate Julia Sutcliffe with an excellent presentation. Indeed, probably stole most of my sandwiches. But the reality is, what I will try and do, it's a great perspective. From a developmental and manufacturing perspective, there are some real hard lessons, as it were, from a maintaining and actually operating perspective. The security aspect gets right in the way of much of what we try and do, as well as the airworthiness and safety regulators. Now, that's not to say that we want to be unsafe or profligate with the lives of our aircrew. But the rules can be very difficult at times to get through. If we actually think that back in 1903, aircraft flew for the first time only 115 years ago, the life of the Royal Air Force has in fact been entwined alongside technology throughout all of its life. And it will go on to continue to be so. 80% of the people working inside the Royal Air Force have a requirement, as it were, for some technological skills, and it's becoming more so almost every month, every year as we go on, which again, if we just look and see what it is that we all of us are trying to do outside, which is to promote as many youngsters taking up technology and science and engineering and maths, as it were. The reality is the challenge needs to, we need to be working harder at it. So moving on, the scope that I want to look at is very quickly kind of flick through with just a couple of highlights of the last 100 years of engineering in the Royal Air Force. We'll take a look at the next 100 years as to what that holds. The challenges and opportunities is the area where indeed it might sound quite depressing at times to hold how hard it is going to be able to bring some of the new ideas and technologies into service. Our challenge is to do absolutely that. It doesn't seem at times as if everybody is on our side to do it. And we'd be foolish if indeed we tried only to think about technology in a straight engineering sense. Of course, there is no technology, there is no innovation without people. And I'll cover a human dimension at the end. Now, many of you may have seen in the press that the first 4 F-35B aircraft destined for the United Kingdom. We own 15 currently, and the first 4 landed at RAF Marham, their new home base, as part of 617 Squadron last Wednesday. The reality is the United States Air Force are currently planning to fly this aircraft through to 2068 and probably beyond. And therefore, right there, what we're seeing coming into land at RAF Marham last Wednesday actually is the vast majority of the next century of the Royal Air Force. So we already know what it is that we have got alongside the Royal Navy to fly these particular B model aircraft off of the carrier, what you see is indeed what you will still be seeing in 50 years' time. So we actually know quite a lot about the future already. Let me just start with a video about the last 100 years of the Royal Air Force.
100 years of courage, of capability, of innovation, of achievement. Let us commemorate the service and the sacrifice. Celebrate our first century of excellence and inspire the service of the future. Look to the skies and look to the stars, for they are ours.
Thank you. Well, that covers the first 100 years. I've seen that video so many times, and the hairs on the back of my neck still rise every time I see it. Just quickly, the organisation that I'm part of, it's a joint organisation, mainly built up with civil servants operating out of Filton in Abbey Wood, just on the edge of Bristol. The Defence Equipment and Support Organisation, our responsibility is to bring both ships, tanks and aircraft into service and hand them across in good order with all the training notes, with the simulators, the synthetic training and all the spares and modification support that may be required for through life for those equipments. And often we are the organisation that is pilloried, as it were, by the National Audit Office for being too expensive, for being too slow and for missing deadlines. The reality is, think hard. In the last 4 years, have you honestly seen many of those headlines? Honestly, as taxpayers, I can talk to you and tell you that indeed we are getting much better. Can we still be better? Yes, of course, but we are getting better. That's the organisation. There are 11,200 people in it. I'd be very surprised if, in fact, we don't feel some form of efficiency cut sent upon us as part of the Modernising Defence Programme later on this summer. With some tweaks, we can always be more efficient, and we're working hard to do that. So we're the organisation that faces off to industry, articulates the customer's requirements from the front line, writes a contract and a commercial arrangement around that, and then project manages that piece of kit, that service, into the hands of the armed forces, and handing over something that is safe to operate. It isn't necessarily safe when they operate it, as it were, for who they are intending it for, but it's certainly safe as we hand it to them, and that is the target. You heard a little bit about the budget. £14.2 billion core spend across the DNS for the front line. My own bit last year was £3.5 billion of the work that I put to work, money I put to work for the Royal Air Force within the air domain. The interesting point, actually, because it's very easy to get swept away with the bright, shiny new toys and thinking about innovation, some 62% of the money that we put to work actually buys spares and actually supports the equipment and services that we already have. And so we're working really hard, as it were, to try and to increase the efficiency of that, so it actually allows us to actually go and buy more bright, shiny toys. A third of the budget is spent in the United States dollars and euros, and so it would be fair to say that Brexit gave us a bit of a hit, as it were, with the exchange rate immediately after the referendum. It's starting to bounce back now, but it is something when we look at actually where we're getting our technology from, not all of it is actually homegrown. The best at times we can often achieve is the piece parts, as it were, and the components and systems that are actually then incorporated in the aircraft and systems that we're purchasing from around the world. My job is truly international. I program chair the A400M with 6 nations. There was an F-35 gathering, a governance gathering last week in Washington, where 9 nations sit around the table. And I have to say, from personal experience, one's attitude changes when in fact you sit behind a Union flag and suddenly realise you are speaking on behalf of the United Kingdom with other partner nations, trying to get the best deal, as it were, out of what it is that you are looking for. That particular challenge is something which I won't talk about anymore, but it is a very real one of actually trying to align in an international forum the requirements across international partners, the political will to actually go ahead with a particular purchase or acquisition of equipment or a service, and then most importantly, getting the money in the right place and in the right profile. And just when you think you've got there, blow me down, but a general election comes along in one of those countries, and in fact, sometimes the direction of travel can change completely. So there are other challenges, as it were, outside of just simply trying to get technology in. If even what we've heard from Julia, and in fact, when we hear about it, it is absolutely what we want. It's exactly where we should be and hopefully will be in not 100 years, but much, much sooner than that. The reality is often it can be so very bureaucratically challenging to make it happen. That's the portfolio that I look after. So Typhoon bottom left all the way through up to F-35. There's a Spitfire somewhere on there, and clearly comparing it to the F-35 is, well, hopefully it will make a very good camera picture at RIAT this year. 100 years of ingenuity and engineering. 3 different marks of aircraft there, going all the way from the First World War through to our very latest cutting-edge technology, the most advanced aircraft anywhere in the world. And on the right-hand side, the history of where that came from. One of the great things that come out of RAF 100 is the baton. And there is Air Commodore Charles Clark, an ex-POW, who was actually in Stalag Luft 3 and was on the Great Escape, was not shot, clearly, and went on to live a very long life, 95 years old, holding that baton and handing it on to actually aircraftman Adam Wood, who is the youngest member of the Royal Air Force. The baton itself represents the history of the Royal Air Force, made up of 3 parts. So there's a main core to it, that's the Royal Air Force, and there are 2 wings. You can just see those at the top of the 2 aerofoils, one representing the Royal Flying Corps and the other one the Royal Naval Air Services. The handle is wood, so that goes all the way back to the First World War. The core is aluminium, and that's the 3rd and 4th generation aircraft, and the aerofoils are made of titanium, so it looks like the future, as it were. So an awful lot in one story. We're very proud for it to be our 100th birthday, and we mustn't forget that part of the celebrations that we're undertaking is also to commemorate the past. But I think from here on in, what I'm really trying to do is inspire everybody for the future. And that, of course, is the 3rd theme of RAF 100. So across the years, in many locations, the Royal Air Force has indeed been excellent at its engineering. Honed skills by actually getting around problems in very strange parts of the world, in various locations with various tasks over the last 100 years. Increasing in technology, always becoming smaller, it would be fair to say, but actually no less capable. So where, in fact, if we look back at just 1982 and the daring do, as it were, of the Black Buck raids on the Falkland Islands, the bombs came out and fell vertically, as it were. Just this short period of time, aircraft can carry almost as many as a fast jet combo, as it were, and can literally put a bomb on a handkerchief at about 8 miles distance, long before anybody knows it's there. So the technology is moving ahead at pace, and we hopefully are keeping up with it. History has taught us, indeed, that innovation has often been the deciding factor through conflict. And indeed, if we just look and see how much innovation there is in times of conflict, the rule book often is not necessarily thrown away, but it's prioritised, it would be fair to say. And indeed, when we look back at how much innovation there was in the First World War and the Second World War, and we just look at the history of the Air Force's contribution. So whether it was radar, air-to-ground radar that was actually first invented by the Air Force in 1936, whether it was paste that was smeared onto the leading edges of wings and of propellers to try and combat icing, whether in fact it was high altitude use of oxygen for our pilots at a very high altitude. Clearly all of the ejection sequences and getting people out of aircraft at dangerous times. It also comes all the way back to Sir Frank Whittle, who was wearing an RAF uniform when he invented the jet engine. And if we just look and see what those 100 years of innovation in just a couple of very quick snapshots. So why is that picture there? Simply because it's lovely to look at. But it does show, as it were, the level of technology, propeller with piston engines, as lovely as they sound, but there was a limitation to them when indeed Sir Frank Whittle was inspired, as it were. There he is on the left-hand side, and there's one of my joys, a Pegasus engine coming out of a Harrier in a deployed location, as it were. How much innovation and how much change had actually taken place through all the way to the Harrier. And I pick Harrier because it's clearly linked very closely to the F-35 with regard to the control laws and the fact that as an ex-helicopter and an ex-Harrier person, it would be fair to say an aircraft's not an aircraft if it can't hover. EJ200, probably our best engine to date. 27,000 pounds of thrust, and indeed there were times when this aircraft came into service that the only opportunities that people had, as it were, to take the engine out was simply to get at other components on the aircraft insofar as it never broke. There were people that almost got through an entire tour that had never actually had to take an engine out and replace it in anger. Now, we've been flying the aircraft properly since 2003, so we've got 15 years worth of experience. And indeed, I must say, I've been in my job 2 years and I almost know nothing about the EJ200 in as far as it never goes wrong from my perspective. That's not to say there aren't a lot of people managing it very carefully from both Rolls-Royce and indeed my own delivery team for Typhoon. But the bottom line is it's an amazing engine and gives Typhoon still a cutting leading edge into the future, an amazing engine. Similarly, the A400M, it's got the most powerful turboprop engines in the Western Hemisphere. The Russians have built something slightly larger now. I hope they have better luck with the gearboxes. 11,000 shaft horsepower, actually going through a suspended gearbox that's sitting just in front of just behind the propeller, getting itself shaken to death, as it were. So we've had 1 or 2 hiccups with that, but it's working incredibly well now. And here again is another aircraft that actually will be in service for the next 40 to 50 years. And so when we talk about the future, we can see it just there. And that is like flying an airline as far as the pilots are concerned. However, it can actually land on a beach, it can land on rougher terrain and softer terrain than the C-130J and K that it replaces, and it can carry 86% more in terms of capacity. And because it's so clever, it can fly itself. The reality is, you speak to the pilots, you think, gosh, I'm sure they won't like that very much. The reality is they love it because what it actually does is give them so much more capacity back to operate the aircraft in a tactical location and in a tactical way. So it means that they can make it work better for them. So it's interesting. And there we are with the F-35. Again, in the hover mode there, it looks pretty ugly when it does that, it would be fair to say. With the lift fan engaged, with all that air, as it were, through something you're dragging around for just those moments you need to use it for short takeoffs and vertical landing, and the whole of the engine at the back, the rear end, just nozzles through 90 degrees and faces downwards. Truly incredible technology, absolutely amazing to watch. And as far as we're concerned at the moment, it's going very well indeed, touch wood. And it can hover, so it's got to be great. If we look at technology again in just photo reconnaissance, so again, this is a very military role. From the First World War, people were literally strapping still cameras onto the side of aircraft, and technology was simply pulling a bit of string, as it were, so you didn't have to actually have your arm outside holding the button at the time. They were coming down, wet film was being processed, And then for the first time, the generals at the time were able to see actually what was going on just over the next hill, because until then they'd also almost got no idea. Some leap of technology on to Tornado, but still probably arguably third to fourth generation aircraft technology with a Raptor pod. Again, still doing reconnaissance, still this was the first proper solid state recording, and indeed has made such a massive difference to the military capability in Iraq and Afghanistan. And in fact, the Americans were tasking it probably more than we were, because of the great pictures and the great turnaround times that we're able to get off of the aircraft. Sentinel, with its synthetic aperture radar, again in getting the most amazing pictures, and again most of the NATO contribution that we make with our iStar platforms is made through Sentinel, and it's visionary and imagery that others just simply aren't able to get in the same degree of clarity that we're able to do with our 5 aircraft. So it's a very small force, but very capable. And again, lots more of that in the future. All the way through to Carbonite 2, the Royal Air Force's first satellite. It's relatively low money, paid for through Surrey Satellites, a part of Airbus, but very sensibly left alone by Airbus to be as innovative indeed as they have in the past. It's about the size of a washing machine, and it's taking colour, full motion video from the skies, and we're able to beam it directly into the cockpits of aircraft at the moment. And again, this is a first off anywhere in the world, and it went operational the middle of January, and it would be great to have a constellation of those at some point in the future, if not only for ourselves, but indeed when we look at interoperability with international partners, because it's almost impossible to think that we as a United Kingdom would in fact be acting independently in any way, shape or form, in any form of really Article 5 aggression in the future without coalition partners. So sometimes it's some of the things that one has, one doesn't always need all of them yourself. Sometimes it's a case of trading for something else that somebody else has that you would very much like. And this gives us that type of tradability. And 100 years of technology challenge. Engineering, I think, has been, it would be fair to say, an enabling function throughout. Always listening to what it is the requirement is from the operators, from the aircrew, and then providing it to them in the way that they want it, tweaking it, getting it better, feeding it back into industry, setting requirements, and allowing the great powers of industry and the innovation and the research and development budgets that they have, partly funded by us, partly by themselves, to actually then come up with that next brand new idea. So let's quickly look at the next 100 years. Why is it important that we innovate? In very simple terms, if we don't, we will actually be outpaced, as it were, by our potential enemies who are more agile than us. And indeed, whilst that picture there is of a backfire bomber, and the interesting part of it, that picture was taken in the beginning of March over the North Sea with an aircraft alongside it. The reality is it was only actually made within the last 3 years. So whilst the Russians are making these things and are flying them over the North Sea towards us, so the technology is very much there. But of course, if we look at top left, what we have there is white vans doing dreadful things on the streets of the United Kingdom. And so there's very little, as it were, cutting edge technology in its truest mechanical sense can do about that. What it's then going to come down to is intelligence, it's picking up its surveillance, its reconnaissance, the processing of all of that data and doing something about it. Open systems are proving successful, and I'll come back to those later. Budgetary pressures are always going to be there. Whilst indeed we are blessed with an increase again, higher than inflation, as far as the UK economy is concerned, into defence, the reality is, even though there's going to be 3,200 F-35s, the batch orders and indeed how many aircraft are being made are so small in comparison with what's going on in the civil sector, it still means that inflation on equipment is running at around 6 or 7%. And so we continually need to work hard to keep the prices down to make sure that we can get as much capability as we need for our armed forces. And of course, technology, as we've already heard very eloquently, is just moving ahead at such pace. And so if we are going to be part and relevant in the future, then we have got to embrace that technology and actually put it into our equipments and continue. And more about how you do that, as it were, with an aircraft which we've just had brand new and we're going to keep for 50 years. So how might we do that? So in simple terms, we've got to embrace novel technologies. And COTS and MOTS, commercial off-the-shelf and military off-the-shelf, are key features. I already mentioned that we're buying a lot of equipment from the United States and from Europe in collaboration often, or indeed sometimes it's straight off the shelf. The P-8 Poseidon there, 9 maritime patrol aircraft. The first one will fly on the 1st of October in 2019, I promise you. I have had a bet with Boeing for £10. It's £10 versus $10. It's whichever is the highest at the time. But I know that it will. So with regard to increasing the operational performance, what we've really got to do is often it's spinning off of what's going on outside and bringing that technology into the military. If it is highly secure, then the reality is it's probably going to be us and only for us, and we will have already put the science and technology research and development money into it. But for a lot of the time, we're actually taking other people's ideas and embedding them into our own use. So where technology can help us is not only keeping leading edge technology in terms of military capability, as indeed the P-8 Poseidon, the best maritime patrol aircraft in the world by a long way, and will continue to be so through our collaboration with the United States Navy and the Australian Navy. The reality is we've got to also look at the way it's produced. We've got to look at the way it's supported so that we can ratchet down those costs, so at the same time we can actually get more modifications, more enhancements. The challenge, I already mentioned it earlier, was to indeed make sure that we meet the safety standards and regulate and certify. The interesting issue of entering an international partnering arrangement is that the safety and the regulations against which we bring aircraft into service for a release to service are completely different by country by country. And the way that we go about it, accumulating the evidence, we by far, it would seem, collate more evidence. The 1974 Health and Safety at Work Act says that we have to have demonstrable proof that what we are doing in terms of design is safe. So that means you've got to prove it before you fly it. And simply putting it on a rig for however many thousand hours at this moment is not enough. So there's a huge amount of work to translate Americanese, as it were, into British so that we're able to accumulate the knowledge that we need to be able to get it past our regulators. A real challenge. We're on that case, and there are many ways that we can improve that, sometimes through the use of technology, and more of that a little later. And clearly the other thing is to, with all of the money that goes into research and development, the real trick is to bet on the winner, because it's really hard at times to know which piece of technology is going to give you that edge that you need in terms of military combat. And there are many, about roughly 5%, if you study research and development, is actually going to turn up goods on first time round. So it's a case of recording how well or successful it was to date, why did it fail, put it on the shelf, log it very carefully, because it's quite often you'll come back to it and be able to bolt it alongside something else in terms of concept or physically and actually make it work later. There's never any such thing as a bad idea. Sometimes it's just the time the idea came out was the wrong context. Multi-core processors, hardly new really, is it? And indeed, when we look at the amount of technology, the amount of information that's flowing, how could you possibly do this without a multi-core processor? The reality is, we have not yet been able to prove that a multi-core processor is safe to use. And so whilst we have them in many applications in our aircraft, if they're actually in a safety critical system, the reality is we're actually blanking out all of the other core, all of the other layers other than one. The Americans are no different, by and large, interestingly. And it comes back to the point that I made in terms of international collaboration and how indeed you can sometimes get the right outcome, but sometimes for different reasons. We've in fact done some work with the United States Army for the new Apache E aircraft coming into service, where indeed we wanted a new real-time operating system with use of multi-core processors. We wanted it to be safer because the one that we were inheriting, we were going to find it very hard to regulate. The Americans at the same time were concerned about interference between the layers and from a security perspective, and also a long-term longevity of being able to have a robust architecture that it was going to be able to modify in many years to come. And whilst indeed we came at it from different reasons, we actually were able to collaborate, put the money in, we both got what we wanted for completely different reasons, and we got the same output that was going to be useful to both of us. So COTS, taking things off the shelf and putting it into military use, does offer utility, but at times we've just got to make sure that it actually does meet our need. And it's rare that at times we don't need to have some adaptation of it. And it's a constant debate as to whether we should change the processes to meet the equipment coming in, or whether we need to modify the equipment to meet what it is our needs are. And of course, the reality is it's a bit of both. And so there will continue to be compromise between technology that you can buy off the shelf, and I really don't know why you can't put this on your aircraft and start flying it tomorrow, compared to the work that we need to do to be able to certify it, put it on the aircraft, sometimes modify it to actually meet our own specific requirements. And of course, what we're really looking for is for all software, all signals to behave in a predictable manner. And that's part of the problem. So the problem with multi-core processors is one is security and its interference between the layers, and the other one is there's no safe argument yet to be able to use them. Industry will produce what we need, but the trouble is, again, we use such small numbers of items that indeed it's going to take quite a lot of money to get it through. Additive manufacturing, hardly novel, in use absolutely everywhere. I was at a STEM event in Edinburgh with Leonardo on Saturday afternoon, and in fact some of the youngsters there were employing 3D printing, as it were, to generate different ways of actually making their robots in a kind of ultra robot war style stronger and more reliable. So it's hardly new. The reality is it's very hard to predictably get exactly the same outcome every single time at this moment with the technology as it exists. And so it's easier, as it were, to allow that technology to operate in the production space. And even when we were operating in Afghanistan, people talked, and we certainly looked at it, whether we can actually put a 3D printer actually into theatre and produce spares. The reality is there were 2 aircraft flying in to Afghanistan every day from the United Kingdom, and so it was easier to put the spares on the aircraft and build them in a safe location here in the United Kingdom. I do think, however, in the future that's indeed what we will be doing, and in particular for repair, structural repair, very similar in the way that Julia spoke about earlier. So for expedient repair, I think we definitely will be using this. Actually, where we're using it at the moment, interestingly, is with very high cost avionics. We're actually using 3D printers to produce containers to put them in so that they support. So we are using it, but in a slightly different way perhaps to that others might think. Isaac Newton said, if I have seen further, it was by standing on the shoulders of giants. In today's speak, that is, let's not reinvent the wheel again. Let's actually take the ideas that exist already and try and put them to a new requirement. And so when a new burp technology for rotor blades was done many years ago, it was trying to get blades that could go faster, stronger, better balanced, much more greater levels of predictability, take vibration levels out, and to give them a stronger and much more reliable use, longer term use, through life cost, as it were. What was actually stolen was the design from Concorde wings. 70 degrees of wing sweep is exactly the same as the burp, and indeed the contour of the wing is exactly that you will see in the blade itself. So Mach 2 was working pretty good at 200 miles an hour, at a high angle of incidence, and was working perfectly. So sometimes it's a case of taking technology that already exists and utilizing it in an innovative way that nobody perhaps else might have thought about. With regard to software, I mentioned open systems architecture, and this is a real prize. So It would be great, as it were, to get away from intellectual property rights, to get away from single source buying from particular manufacturers who at times then feel, as it were, that it's very hard to get a competitive deal. And in the way I've already described, F-35 is going to look like the F-35 for the majority of its life. Inside the computers will be upgraded, but most importantly, the software will be changed on almost a continual basis. There is a challenge as to how you do that and certify it on every single time, so there will need to be a drumbeat, but it will be certainly more continual than we see now. And so there's a great project that we are undertaking within the air domain, along with BAS and 16 other companies, some of which universities, and trying to get to the perfect international standard of open system, so that simply you are able in the future to be able to plug almost anything into it. It sounds so easy to study all of the standards, understand the pros and cons of it, and make it work. So that as indeed one brings something along, whether it's old technology or putting a new software wrap around it, it actually then is taken as to, all you get is the core functionality out of the application, as it were, and it will enter straight into the aircraft. That will also do away with some of the preclusions and constraints that we have of exporting military technology, because it truly is a vanilla aircraft or a vanilla piece of equipment. Then there are no secrets that are actually transferred from one particular manufacturer to another, or from one country to another, and no intellectual property going either. And it does mean that, again, through-life support will be much better in the future, and indeed it means that we'll be able to change the level of technology, the level of capability, the extra go faster strike that may be needed, we'll be able to put on in the future. AI and autonomous systems, certainly doing the dark and dirty work. We're seeing more unmanned aircraft. Indeed, there will be one airborne from the Royal Air Force over Syria and Iraq 24/7, and has been now for the last 4.5 years, doing what it does, as it were. And it is AI with very extensively researched algorithms that is allowing the aircraft to be able to fly very safely and perform their missions. There are issues about safety. Indeed, the software for the Reaper aircraft that we fly, we don't, again, through intellectual property and commercial constraints, get to see all of the software and how it was actually written. And therefore, there are constraints that we're having to impose upon the aircraft and where it's actually used. But nonetheless, this is definitely the way forward and is moving forward at speed, and we are definitely making use of it within the Royal Air Force. And the swarms and robotic wingmen, they're not there yet. Yes, they're on movies. Yes, they are in research labs. We don't have any yet, and yet there are experiments of actually operating unmanned aircraft from manned helicopters at the moment. And indeed, that's something, again, which I'm sure that we will see in the papers and actually bring into service within the next 10 years. Cyber, the tax on technology is what I call it, in as far as everything runs on software, and therefore, whilst indeed at the high-end level of offensive cyber, and really the only legal way of doing that is from within an armed forces with rules of engagement, the reality is so much effort and so much expense needs to go into protecting us, protecting our equipment, protecting the very vital networks and the information that indeed we make use of, that gives us ultimately the military edge that we need to perform those missions. It will continue to dominate the spend and indeed the technology, the research and development, because it's a continual battle. Every day, the bad guys out there, some of them state actors, are trying to penetrate our networks, as indeed they are networks across the entirety of this country. And whether it's either stealing ideas and technology in itself, or indeed information, secure information, it doesn't really matter, but it's happening the whole time. We have we are embracing this, and the Royal Air Force is right at the front of the Defence Cyber Force in the future. So many of our people, indeed, again, through the high level of technology in aircraft, have got the skills that are required to work in this area alongside government agencies that, again, we're very much engaged in that, and it will dominate, I think, the entirety of the next 100 years in the way that it has the last 20. I spoke about unmanned aircraft. Protector is probably one of my favourite projects. It's not necessarily one of my most important, but it's certainly one of my favourite. It's a Reaper built by General Atomic in California on steroids. It has a really large wing. It has 6 hard weapon points. It can take all the up-to-date sensors. It's got a larger engine, carries more fuel clearly with a large wing. We're putting into it a sense and avoid radar at the front, and this could very well be the first unmanned aircraft, or at least that's the plan, that will fly in congested airspace over densely populated places like the United Kingdom, and hopefully keep us safer. Now, I'm sure that there is still going to be an ethical argument about whether they should be there or not, but ultimately, with the level of danger that can exist, has existed in our country in the last 2 years, I would say this is a pretty good bet to actually do something about protecting us. But really great technology. What we're doing very specially about it, again, I spoke about Reaper and some of the challenges that there are in terms of trying to make that American aircraft fit our own safety regulations and requirements. I've had a team over in California for the last 4 years helping design it, and we're designing it to meet UK specs. So if in fact we're the lead customer, if we can do this, the great thing is I think many other countries across Europe will want to buy into this technology as well. And indeed, we will then have a great, as it were, European force of this particular type of air vehicle, with, of course, us in the lead. So that might actually make the through-life cost lower. If it's lower, it means we can enhance it more. It means we can have greater levels of technology doing what we want it to do. And indeed, the diagram there in the top right shows some of the standards, as it were, and how they actually fit together as to what it is that we've got to do to be able to qualify and certify it through to a full release to service with the aircraft due to come into service in 2023. Future combat air systems, the bit that's perhaps the most exciting. At the moment, the MOD is working on a combat air industrial strategy. It will be publishing that within the next 6 weeks or so, and I'm rather hoping that there will be some good direction as to where the next chunk of science and technology research and development money to make use of Project Pyramid and actually start to bring that to life, as it were, alongside other elements of technology. What you see there, again, is previous pieces of research and development worked in this particular instance alongside British industry led by BAES, and we'll see what comes of that strategy. I spoke about targeted research. I spoke about technology development and drawing on experimentation. Those are all things that we should be doing. We never quite have enough money, as it were, in the budget. It's very difficult at times to prioritise precisely into what it is that one wants. But when we look at future combat air systems, this is, of course, what genuinely makes the Royal Air Force what it is, so that it can defend the United Kingdom, and therefore has one of the highest priorities, as it were, in terms of looking and seeing what the future threats are, and to determining what items of equipment not often will actually change the outline profile of the aircraft. It could well be to have a sensor that has a better algorithm, so it can actually identify what it is that it's actually seeing with a higher degree of probability and certainty, such that it can actually give the pilot the information so that he or she may be able to take avoiding action if indeed that's required, or indeed, most importantly, bring it home or transmit it home to be part of the overall jigsaw of an intelligence picture that actually, again, recognises where the next target or the next threat may be coming from. International by design, again, it's an interesting point that's been reinforced within the last defence reviews. The reality is that we can only do these things in a shared collaborative way in the future. It is then a case of deciding, and it's a case of wanting to decide who we join, who we allow to join us, rather than who we join. That would be a great place to be, and indeed certainly is where we have been in the past, and certainly is our ambition in the future. Future weapon systems. So if in fact one is not going to change much the outline of the aircraft, and it's all going to be the equipment, the sensors inside, the software, then it is going to be the weapons. The next generation of weapons, Spearcap 3, will be network enabled. So what does that mean? It means you'll be able to reprogram it actually whilst it's in the air. You can redirect it to where it needs to go if in fact the target moves, or indeed, most importantly, with the rules of engagement the United Kingdom forces operate by, as a civilian casualties 0, and something happens, then you can alter the weapon's trajectory and decide what to do even whilst it's in the air. Future cruise and anti-surface weapons, the next generation of those are alive and well, and indeed where the real innovation will come is through miniaturization of all of the things that one can put into an aircraft, of actually putting them into the weapons, so that actually you can get the greatest level of technology into the weapon to make sure that it gets there, maybe even with its own self-defense suite, as it were. Chaff and flare, radar jamming, all sorts of things can actually be inside the aircraft. And recognizing that the weapons of the future won't simply be explosive. Indeed, it could be an electromagnetic pulse that actually takes out the electric substation, the power, as it were, of the target, where in fact, by and large, then you can actually perform things without hurting or harming individuals per se. That would be an ultimate game changer. And if indeed we thought that we were able to miniaturize laser-directed energy weapons, you would actually have an unlimited arsenal sitting in your aircraft. And all you actually need the thing to do is charge up between firings. So there's no very lightweight aircraft then, no great need for kinetic bombs per se, but to be able to do what it is that's required through the use of technology. Challenges and opportunities, and I'll whiz through. I've already spoken about technology as to the difficulty, as it were, at times of being able to capture it, grasp it, know precisely what it is that one should be putting the money into that's going to give you the best bang for the buck, as it were, and then most importantly, getting it onto your aircraft quickly enough through all of the safety regulatory frameworks to be able to make the difference as quickly as it's needed. And innovation, absolutely vital to how we do this in the future. I always spoke about COTS, and indeed I think as we look to the future, it's certainly as civilian as possible and as military as necessary will definitely be the prevailing phrase, as it were, as we look to the future. Because again, the runs that we are interested in often are much smaller. This aircraft here, the River Joint Air Seeker, it's one of 20, we own 3. So it's very, very small numbers with the greatest levels of technology that's sitting inside a 1950s aircraft design. Absolutely amazing technology inside it, continually needing to update that. Rapid development, from the way I described earlier and how we're going to get around, I guess, the regulatory framework to be able to upgrade things quickly enough, it's got to be, do we have to test everything and then evaluate whether it met the test? Are we able, through many much more cleverer ways of actually running equipment on rigs, as it were, for thousands of hours, and in fact then understanding where the vulnerabilities are and testing those. So these are some of the ideas. I'm absolutely certain that's where we will get to through laboratory and simulation, that indeed we will work out what it is that we should be testing, where are the high degrees of probability of failure. Let's test those to destruction, understand precisely then the outcomes, and actually get the piece of equipment onto the aircraft much more quickly. So we've got to be continually challenging the way we're thinking. And again, through use of AI and the algorithms that allows us to do, to apply, as it were, to this, to be able to test things from every single angle, every different conceivable failure mode, is again how we will get things onto the aircraft more quickly. And technology demonstrators is definitely the way to go again, in doing things in small scale, in small numbers, with a relatively low budget, as it were, and really testing it as to whether it works. Before indeed one then invests in the larger full-blown model. But we mustn't forget the people in all of this. I've already mentioned that indeed technology, and that doesn't work, indeed, and neither does innovation, clearly, without people. We're very proud of our workforce in the Royal Air Force. In this last year, we met all of our technical, for both aircraft technicians and indeed our engineer officers. We met all of the recruiting target for the first time in 8 years, and indeed it was the highest target for 8 years. So we're working really hard with schools and colleges to make sure that we get the best and the brightest come and join us. The right people, the right skills, the ability to think differently. Our youngsters are different. Our youngsters are certainly different to when I joined. They are so much more worldly wise than when I joined. I think I'd been to Paris once. Most of our youngsters joining over here will have probably been around the world at least once. They will know so much more. They will be questioning, they will be challenging. They are exactly the people that the Royal Air Force needs in the future to be able to do our job. We provide world-class training to then bring them close to cutting-edge technology, and from a whole force approach, we are truly in a long-term, no other way of doing it, partnering arrangement with industry, and British industry preferably, but ultimately, again, international by design. We will do it with other nations and overcome the hurdles to get at the best technology that we need to do the job. We're doing our bit in the way that the IET is actually doing a fantastic job in promoting STEM. The Royal Air Force is making great use of the banner of Year of Engineering 2018. We should all be out there doing our bit, as it were, either encouraging the youngsters themselves to be interested and curious, or equally in allowing our people who work for us a little bit of time off, as it were, for them to be able to go and do it. In reality, nobody wants to be taught as to how a go-kart might work slightly better from a grey-haired old person who looks more like their granddad than indeed their brother or father. So it is a case of getting the youngsters doing this, and it's working really well. Big Bang this year, the defence sector had the largest, we were proud to have the largest footprint in terms of square meterage at Big Bang. Fantastic event. We were very proud to support it alongside industry partners and indeed, again, all of the professional engineering institutions. Again, it is about the future. And in reality, for those youngsters that I saw in Edinburgh or on Saturday afternoon with their go-karts, the loveliest thing was, yes, they talked about last year, and they said that what they'd done was they'd actually used last year's failures to improve. And the nicest thing, the greatest thing, they spoke about next year, how they were going to make it even better. These people are restless. They are not content with what it is that indeed they have done. They can only think about how it could be improved and how it could be bettered in the future. Honestly, with those people in the United Kingdom, with those people forming members of the Royal Air Force, our future is safe in their hands. Future of the Royal Air Force, it looks like that for at least the next 50 years. It's going to be a great next 50 years. And so again, coming back to what are the themes of RAF 100? They are about commemoration, and indeed I have spent some almost eye-watering moments with the most amazing veterans and hearing about their stories of indeed the things that they have done for the protection and advancement of our country. Celebration, yep, we'll have a great party in London on the 10th of July. There will be 100 aircraft that fly over Buckingham Palace. There will be 3 F-15s in there. Sorry, 3 F-35s. F-15s. That's international partnering gone mad, isn't it, at this point? There will be 3 F-35s. It's going to be great. But most importantly, it is about inspiring the future. That is the future. It landed alongside 3 others, and there'll be more to come. Thank you very much indeed for your attention.
Well done, sir. Do you want to stay that side? So thank you very much, sir. I'm proud to be serving in our anniversary year and excited about the future. We'll now be taking questions from the audience for Air Marshal Young and Dr. Sutcliffe. We are accepting questions via Twitter using the hashtag IET EngTalks. And now I'm going to introduce you to a piece of technology. This is Catchbox, and it's a microphone that is throwable. My throwing is awful. So I'm now going to throw it to somebody. I apologise if you're sat within splash distance, but I'm going to throw it. If you want to ask a question, put your hand up. This will come to you. It's so that we can capture the question and the answer for those at home for later. Are we ready? Yes, that's my bit done. So, who would like to ask a question? Oh, come on. Who's going to... Yep, perfect. There we go, chap in the white shirt. That's a long throw. Oh, well done.
Okay, we have it. Well, thank you both for a very interesting presentation. I have a question in respect of the thoughts that you have in respect of the F-35 being around for that length of time. As Julia mentioned, the robotics is getting more and more intelligent and becoming more intelligent than humanoids. So I think the weakness in the F-35 is the pilot in the cockpit.
Well, clearly, as an engineer, one can hardly say anything nice about aircrew, clearly. All they ever do is break my aircraft. The reality is, the debate of whether it's going to be unmanned or manned in the future, I think is still yet to play out. And indeed, the point I made about rules of engagement, and the United Kingdom is very proud of its very tight rules of engagement. And there have been many occasions, indeed, over Syria and Iraq in the last year or so, when in fact the debate that's gone on in this cockpit of a Tornado between pilot and weapons system operator in the back as to what it is they're looking at. Are they absolutely sure that what they can see are the bad guys, or indeed is it the good guys looking like the bad guys? I think for some time to come, with the level of collateral damage, and I'm sorry that we talk about weapon dropping, but ultimately that's what the Royal Air Force does. It is what sets us aside from Virgin. Because 8 hours in a Virgin aircraft is not that big a deal. It was a pretty big deal for the people who flew over the Atlantic in a single seat with 5 tanking brackets on Wednesday. I think for the foreseeable future, there will be manned aircraft, because I think you need a higher degree of intelligence in the cockpit that can truly make a decision on the spot for some time to come. But I think, I'm very excited about the Protector program. I'm very excited about the fact that for the first time it looks like we'll be able to do something over this country with software that we can certify against an aircraft design, again, that we can certify. So it takes a long time to get this right. So I think we will have manned aircraft for quite some time.
Wonderful, thank you, sir. So, how far are we going to get this box thrown? So, we've got a question over here. See if we can do it.
Okay, no, we're going to go halfway.
Oh, well done. Fantastic.
I was going to ask a question in regard to something Julia said about the level of control systems can take over dependent on monitoring stress levels of the people using them. I'm really interested because at the moment the Red Arrows are undergoing a project to study their performance under stress and whether it improves it or worsens it. And I was wondering whether, if it shows it improves it, will that feature of any system be redundant, or will it actually improve it more?
Do you want to take this?
Sure, yeah. I think we're on a journey, aren't we? We've got capability, technology, software available today, and as Air Marshal Young described, we've got to explore where that gives us a benefit. It's definitely a journey. We are looking at how things like physiological measurements and stress monitoring would allow us to support the human operator by either reducing the amount of information that's presented to them, or perhaps by increasing the amount of control that's undertaken by a system in certain cases. It's a vast space to explore, but explore it we will.
Perfect. Thank you very much. So let's try and get one at the back. Go on, somebody be brave. Oh, got a chap in the middle. There we go. Oh, that's not a very exciting throw. Try that again.
Thank you.
Let's try again.
As a lightning protection consultant, I'd like to ask a question about the development of data, operating huge amounts of data, presumably ever lower voltages and their susceptibility to electromagnetic radiation, whether that's hostile or a natural environment, in aircraft which are no longer metal but of composite construction, how you see that and keeping our aircraft and data safe?
You're absolutely spot on. And again, it comes down to the compromise between grasping the technology and actually then putting the data that you're operating through the system at risk, either from a safety perspective and as far as the ones and noughts don't get through, or indeed losing them to somebody else, a third party. As we look to the future, the cleverness that we can bring in could almost be our own demise at times from a military capability perspective. Aircraft are still tempest tested, perhaps in the way that you alluded to and certainly spoken about in the past. Interestingly, one of the things that's actually the Protector has now got with it to actually protect it from lightning strikes, because the current unmanned aircraft don't do that. But what it's actually brought in, ironically, is General Atomic have now brought in robotic painting of the Protector aircraft, because it's put on it, because we wanted it to put it on to protect it from lightning strikes, a copper mesh into the external part of the structure across the entire fuselage. And of course, the copper mesh won't work above a particular thickness of paint, because up until now they've just been spraying it on, and it never really mattered how thick it went on. Now, of course, it's got to be done with precision, that's the word, thank you.
Sorry.
I almost come up with prescriptive, that was wrong. Precision. So it's interesting how one particular requirement is actually driving other technology within, again, some companies within our small and medium prize enterprises. And one of the things I should have said is, I think that's those companies are probably where the greatest level of innovation is going to come from in the future as well. But it's going to be a compromise, and we know it is.
Fantastic. So we've got a hand waving behind there in the back seat. Oh dear. Oh.
Health and safety got mad.
It's definitely innovation. Yes.
Oh, thank you. I got
still
it.
Works.
Thank you, Air Marshal Young, for a very interesting your thoughts and presentation. I had two questions, really. The first one was, you said there is a lot of evidence required by the Health and Safety Act that you need to accumulate over a period of time, but yet the design for this military aircraft is all done in the United States, and they're very, very secretive about their software and so on. So I was just wondering, how do you actually penetrate that part of it where the design is actually made is in the United States, but yet they're not willing to release all this information to us?
So, I mean, that was the point with Reaper. And as far as we haven't got full access to all of the software coding and, most importantly, the architecture, and thus that's why it's actually being flown under a risk case at the moment. And indeed, that particular aircraft will almost never fly over the United Kingdom. So it is flying in training, as it were, over the Nevada desert in the States through our pilots via satellite link, either there or indeed out of RAF Waddington in Lincolnshire. It's flying at the moment out of Kuwait over Syria and Iraq because, quite frankly, it's a war zone, as it were, in terms of where they are specifically flying. And that level of risk, as it were, has been accepted as acceptable. So there are constraints. It does come back to the point of some of the limitations of international collaboration. Technology is so very expensive, firstly to capture it and then productionize it and put it onto your aircraft. There is almost not a way that you could do it within the United Kingdom on our own, and therefore it has to be through collaboration. It has to be through great levels of partnering arrangement, and indeed why I seemingly spend so long in Terminal 5 at Heathrow, waiting to fly for the next meeting to be able to collaborate with our international partners to the extent we take things for them, because we're pretty innovative in how you can operate something, but often in terms of the hardware, we are having to work hard, as it were, to ensure that we get all of the information that we need. And just to clarify, we're not chasing health and safety itself. That just happens to be the law, as it were, that says when you want to operate something safely, you've got to have demonstrable evidence that it is safe to an acceptable level. And for aircraft, it's at 10 to the minus 6, as it were. It's a very simple rule, and therefore that's what takes so long to accumulate the evidence to prove that what you're going to put airborne is going to stay airborne.
Okay, so let's try and see if we can get a question over here. It's not that I want to see the thingy fly everywhere. So we've got a question over here. Where's the box gone? Oh. I feel like we ought to have a drum roll or something. Oh. This is like the lightning appearing. It's got like fueling stops.
Yeah, it is,
This was a question. So from the engineering side of things, you talk about developing the software, making components smaller, making everything lighter, and obviously from developing new technologies. And we've had the Tornado for 30 odd years now. So when do you decide to go from upgrading old technology to bringing in a whole new aircraft like the F-35?
As the soon-to-be chief technologist, I'm going to put you on the spot.
Well, I guess our challenge is, having created aircraft, and as Air Marshal Young said, F-35 will be with us for the next 50 years. That's what the next 50 years looks like. Where we need to innovate and use our collective brain power is to understand, how do we keep those systems relevant? So how do we continuously refresh some of those clever software algorithms and capabilities on board that keep that aircraft system at the forefront? And that is challenging, and it's hard and it's difficult, but fortunately we're a massive team of clever people in this country. I think we can do that, but that is our challenge. It takes such a lot of money to create an aircraft system that actually you want it to last as long as possible to get your money's worth out of it.
In 2003, when we embarked on the F-35 programme in international collaboration, we had no idea that indeed the government policy as of 2010, when the Harrier was taken out of service, that for affordability grounds and indeed a bunch of common sense reasons, the decision was made for the Royal Air Force to have principally two aircraft in each individual role, which is why when Typhoon came into service, Harrier went out of service with Tornado, and now while F-35 is coming into service is one of the reasons why Tornado is going out of service. So it is indeed picking up new technology and trading, as it were, for older technology. The Tornado will continue to fly with the German Air Force and probably the Saudi Air Force out to about 2030. It is an incredibly capable aircraft, but we will end up with a more capable aircraft. So it was government policy to get down to two different types, two helicopters, Puma, Chinook. So it works quite well, quite simply.
Perfect. So we've got one last question, and we're going to take a Twitter question. Just need to find the...
Oh, sorry, yeah, I've got it.
It's okay. Just needs to come into the centre. Oh, we're going to do a standard catch. Yes.
Right. So we've got a question from our audience on the Twitter. Graham Pate, how long do you see the H-47 serving for? What, if anything, will replace it? And another question from myself, if I'm allowed. You showed some of the Russian aircrafts already flying over the UK or near the UK. President Putin unveiled some fantastic technology in his speech just before he was re-elected, with some sort of autonomous aircraft flying all over around the Earth, and then still managing to aim at some holiday homes in Florida. So does RAF need a disruptive technology for that?
Can you just repeat the first question? Was it CH-47, did you say?
Yes. How long do you see the H-47 serving for, and what, if anything, will replace it?
Okay. Well, at this moment in time, there is no plan to replace the CH-47 Chinook. Before I did this job, I did helicopter acquisition. And in fact, I brought the last 14 Chinook Mark 6 Chinook into service. So the Royal Air Force currently has 60, which is the largest Chinook force outside of the United States Army. It is, without a shadow of a doubt, in my view, and that I may be biased because I used to be the junior engineer officer on 7 Squadron, the Sengo and 18 Squadron, the best battlefield support helicopter anywhere in the world. It is as good as it gets, and indeed it has kept up with technology. So we have the very late, 14 of our 60 are the very latest technology, and there's work in place at the moment to look at some of the older aircraft, the older dozen or so, with a view of actually replacing those over a period of time. So I think we will continue to roll. As far as the United States Army are concerned, they will be flying Chinook CH-47 out to 2070. And I think we will probably be flying them then as well. So the future looks like a Chinook as well. With regard to the resurgence of the Russians, I again would say that again is one of the emerging threats, and that is exactly why we must be agile with new technology. So against the specific threat, okay, but the reality is we've got to, and this is how it is so very difficult, as it were, with so much money from some other countries, as it were, being invested in this way, that to actually try and keep up with everything is very difficult. Again, it really puts the emphasis and importance on international partnering arrangements, where indeed through NATO, we can feel much safer that with paying our 2%, as it were, we are contributing to the safety of the Western Hemisphere.
Perfect. So, to thank both the speakers and yourself as the audience and those who are virtually somewhere else. For you in the audience, I'd like to now invite you to join us for drinks and the technology showcase in the registration rooms, where you'll also be able to see the dictaphone presented earlier. Our next EngTalk, should magically appear up there, is on the 17th of September with Assistant Professor Lai. Don't miss it. Book in. Ladies and gentlemen, thank you very much for your time and good night. Oh, sorry. We thought we might get a selfie with you lot in the background. But I've got to use technology. Hold on a minute. There you go. On here. This is called the thrust stage. So, who's going to smile in the background? Oh, please don't do anything like damaging. Oh, I can't work out to turn it round. So, right, there we go. Who's got the longest arms? Smile, everybody. Oops. I tell you what, we'll do it that way around.
Good thinking.
No, it's mine. Big smile. Perfect. Perfect for Twitter. Thank you very much. Okay.